Welcome to TOC class. Here in this class, I discuss the basic concepts of epsilon NFA. So we already discussed the first problem, that is conversion of NFA to DFA. The method is called as subset construction method. So here the second type of NFA is called epsilon NFA. So what is an epsilon NFA? So it is also a non-deterministic finite automata, but it contains an epsilon symbol in it. For example, in a transition diagram, you can able to differentiate ordinary NFA or epsilon NFA. For example, if the diagram contains only the alphabet symbols in it, then it is called as NFA. If the same diagram has an epsilon flow, then that is called as epsilon NFA. This is the basic difference. Okay, so epsilon NFA is also a quintuple representation in which the input contains the basic alphabet symbols including epsilon, so that only the maximum possibility of states are possible. So if you take input symbol which contains a basic alphabet symbols with epsilon, so if any NFA which is combined with epsilon, then that is called as epsilon NFA. Then the transition function is not only for alphabet symbols, it also be used for epsilon flow. So how can you write it? So this is the epsilon closure calculation. So what is the purpose of epsilon closure? So this is the definition. Epsilon closure of a single state is all transition out of state that is labeled with as epsilon. For example, if I want to calculate epsilon closure for state P, then you should write within epsilon closure of P. So which state you want to calculate epsilon closure value, that state should also be included within that function. Then you check what are the outflow from this P state. That will also be included in this epsilon closure value. For example, I draw the diagram Q0, 0, 1, epsilon, Q1, 1, 1, Q2. So this is the epsilon NFA. How can you calculate epsilon closure value? So how many states are there? There are 3 states are there. For all these states, you should calculate epsilon closure value. So epsilon closure of Q0, epsilon closure of Q1, epsilon closure of Q2. So I want to calculate epsilon closure values for all these states. In the first function Q0, I want to calculate epsilon closure value for Q0. So you should include Q0. Here Q1, here Q2. So whatever the state is available, you should write that state first. Then you check the flow from Q0 with the epsilon out path. So Q0 to epsilon, where it go? It goes to Q1 state. Then from Q1 you refer whether any epsilon outflow is there. No, there is no outflow of epsilon with Q1 state. So it will be stopped. Then epsilon closure of Q1, from Q1 there is no output flow. So only Q1 is there. Epsilon closure of Q2, there is no output flow, only Q2 is there. So if you want to calculate epsilon closure value, that will not be pi. Okay, at least one state will be available. So this is the calculation. So I give the another example for epsilon closure calculation because it is needed for conversion of epsilon NFA to NFA calculation. So this is the second example. So this is epsilon. Let's also be a final state. So there are 3 states are there. You write those states. So in short form I mentioned CL, but in your exam you should write fully epsilon closure. So I want to calculate Q0 value. So first you write that state here. Then Q0 epsilon, where it go? It goes to Q1 state. Then from Q1, is there any outflow is there? Yes, it goes to Q2 state. So you should mention it. The path will not be completed. So from Q1 also the outflow is available. Then you check the Q2 state. There is no outflow, you stop it. Then for this calculation, you want to calculate epsilon closure for Q1. So check from Q1 only, not from Q0. I want to calculate epsilon quotient for Q1. So you should calculate that value from Q1 state only. From Q1, the outflow is to Q2. That's all. This is the answer for second one. And you try the epsilon closure calculation for this diagram. It's for your homework. It's for your understanding purpose only. Okay. Let us try it. So there are three states are there: epsilon closure of P, epsilon closure of Q, epsilon closure of R. Only outflow. So from P, where it go? It goes to R state. From R, it goes to Q state. So P should be included. P, R, Q. Otherwise, you can write it in an alphabetical order as P, Q, R. Okay. Epsilon closure of Q is from Q it goes to P state, from P it goes to R state. So here also the answer is PQR. From R it goes to Q state, from Q it goes to P state, from P it goes to R state. So the answer of epsilon closure values are same for these three states. Okay, are you clear about it? Then the next concept, extended transition function, will be discussed in next class. Thank you.